Hello, we're back at it here. We're going to focus on algebraic manipulation. So, again, in your notebook, direct substitution is always our go-to method for evaluating limits. However, sometimes we don't get a definite answer. So again, pause, write down what you need to, turn it back on. So I have 3 examples for you. We want to find the limit as x approaches 2. So remember, direct substitution is our go-to method. So I'm going to do 4 times 2. I'm just going to do it in my head. 4 times 2 is 8 minus 8, which gets me 0 over 7. And 0 divided by any number is 0. The next one, the limit as x approaches 7 over 4x minus 8. So I have 7 over 4 times 2 is 8 minus 8 is 0. 7 divided by 0, however, does not exist. It is all fun and games until you try to divide by 0. It is not possible. Okay, anything divided by 0 doesn't exist. Now check out this next one. I want to substitute my 2 to take the limit. 4 times 2 is 8. 8 minus 8 is 0 over 0. Now that's different. That's not 0 over a number, and that's not a number over 0. That's 0 divided by 0. This is something totally new to you this year. And this, my friends, we'll circle it, we'll highlight. This is called indeterminate. Okay, this means you are not done. You do not have an answer yet. Your answer either has to be a finite number or 0 or does not exist. 0 over 0 says you are not done. It is called indeterminate, and we need to keep going. And this is where these algebraic manipulations come into play. So here's our options. We must manipulate the function when we get indeterminate. So your options are, you can factor, you can rationalize by using a conjugate, you can use a trig identity or a complex fraction. So there's basically 4 different options we need to play with. So let's take an easy one, for example. Find the limit as x approaches negative 3. Now you don't know you have indeterminate until you do the math. So you might get an answer right off the way, who knows? So I have 4 times negative 3 squared plus 12 times negative 3. Remember, direct substitution is always your first method. Notice my parentheses. It may seem tedious, but I'm not going to get the question wrong. Use parentheses. All right, negative 3 squared is 9. So I have 4 times 9. So that's my 36 minus 12 times 3, or plus, I should say, plus a negative 36. All over 3 squared is 9. This is minus 12 plus 3. Now, just tips and tricks, since you can't use a calculator, I'll do the easy stuff. 9 plus 3 is 12. Minus 12 gets me that 0. So let's see, I'm going to get 0 here, and I'm going to get 0 here. So you'll notice I have indeterminate. I have to do direct substitution first to see what I get. Now, because I have 0 over 0, I have to go back to my method that says, you're not done. We have to try something. So when I look at this, factoring jumps out at me right away. So you're going to recopy that limit down. The limit as x approaches negative 3. It's important. We haven't taken the limit, so we need to keep it there. We're going to factor. We're going to go back to the basics here. And I'm literally going to say 2 terms. My options are GCF or perfect square. And remember, you always want to try GCF first. So I can pull out a 4x, and then I'm left with x plus 3. Okay, and then I'll factor the denominator. So when you have 3 terms, that trinomial, remember it's multiply, add, multiply. I'm going to multiply to x squared, so I know that's an easy one. That's just x times x. I need to multiply to this 3 on the end, but add to 4. So I'm thinking 3 times 1 is 3. They're both positive, which tells me the signs are positive. So x plus 3 and x plus 1. Now I'm going to simplify this algebraic expression by factoring and dividing. The x plus 3 on top can divide with the x plus 3 on the bottom. So I really have the limit as x approaches negative 3 of 4x over x plus 1. And then I'm just going to use direct substitution and go back to that easy direct substitution to evaluate this limit. So I'm going to substitute in 4 times negative 3 all over negative 3 plus 1. So I've got negative 12 over negative 2, which I believe gives me a positive 6. So I started with direct substitution. I manipulated using factoring, and then I did direct substitution at the end to get an answer. We'll try a second one here. So, and please don't just jump to factoring. The only time I'm doing that is if I get indeterminate, 0 over 0. So we'll carefully plug a 1 in. I'll pause it. You try it. See what you get. So I worked mine out there, and I think you can see I've got 0 over 0. Hopefully you did as well. So now again, I'm going to attempt to factor this. So keep the limit because we have not taken the limit. All right, I'm going to stick to the easy one first. That denominator, 2 terms. I'm thinking GCF or perfect squares. I can see a GCF. I pull out the x squared, and then I'm left with x minus 1. Remember, if you distribute it, you should get what you started with. Now I got trinomial again, so I'm thinking multiply, add, multiply. So if I want to get x to the 4th, hopefully you're saying that's x squared times x squared. Now I need a 3x squared. So the x squared is going to take care of itself because we already have that in the problem. I'm really just concerned about the 3. So again, it's a nice one, 3 and 1. And I need them to add to 2. Now the sign here tells me I have to multiply to a negative, which tells me the signs are different. So one's a positive, one's a negative. And I need to add to a positive 2. So I think I want a plus 3 and a minus 1. And you can FOIL it out to see if that's what you get, but it should work out. Now, you might be thinking, hold up, nothing cancels. And you're right, nothing cancels yet. So let's rewrite this limit. I might be running out of room here. This is x squared plus 3. Now you'll notice this bear here can get factored again. It is a difference of 2 perfect squares. So I've got x plus 1 and x minus 1 all over x squared and x minus 1. And then you'll notice you can simplify the x minus 1s, and now we'll reevaluate our limit. We'll plug that 1 in again. So let's see, I'm going to start at the bottom. 1 squared is just 1. I'm going to do this in my head. 1 squared is 1 plus 3 should get me a 4. 1 plus 1 is 2. So it looks like I've got an 8. So again, pause, do what you need to do. I'm going to give you this one to try on your own. So I'm going to pause it, you pause it, work it out, and then we'll compare final answers. All right, so I did get 0 over 0, which again is indeterminate. Let's get that word down, indeterminate. So then I went through and I factored. I had the x minus 5s divide out. Again, this plus tells me that the signs should be the same and that they should be minuses. I had those divide into 1, so I have 12 over x minus 1 for a final answer of 3. I'm going to skip this one thinking we've got it down. And I'm going to get to an uglier one. Number 5. All right, you'll notice there's a beautiful radical in here. Or maybe I should say ugly, an ugly radical in here. So method 1, we're going to try direct substitution again. 1 minus 1 is 0. 5 minus 1 is 4. The square root of 4 is 2. 2 minus 2 is 0. And we end up with 0 over 0, indeterminate. So now if you look at your list of options, there's nothing to factor here. There's no GCFs, there's no trinomials, there's nothing to factor. The next method was rationalize or conjugate, if you look back at your notes. So just to review, the conjugate, if I said x plus 1, the conjugate of x plus 1 is x minus 1. We did a lot of conjugate multiplying in Algebra 2. It's also what you get when you factor perfect squares. If I said x squared minus 9, its factors are x plus 3 and x minus 3. Those are conjugates. One gets a plus, one gets a minus. So this is going to take up some room, and this can get messy in a hurry. It's not hard. It's messy. So you need to keep very neat and accurate here. All right, so I'm going to rewrite this limit, x minus 1 over the square root of 5x minus 1 minus 2. Now I'm going to multiply the conjugate of the radical. So maybe you want to star that in your notebook, highlight it. You're always doing the conjugate of the radical. So I'm going to multiply the top and bottom by the square root of 5x minus 1. The conjugate now is plus 2. And I'm going to do that to both the top and bottom because it's like multiplying by 1. You can do it as long as you're multiplying by 1. And anything divided by itself is 1. All right, so again, perhaps you want to pause it and write some notes off to the side. Okay, I've got indeterminate. I'm multiplying by the conjugate of the radical. And now we're going to carefully do this. So I have the limit as x approaches 1. I'm going to wrap this numerator up. This times this, right here, this times this, I really don't know what to do with it, so I'm just going to write it down. I have x minus 1 times the square root of 5x minus 1 plus 2. Okay, now the denominator is the part where the two radicals are the ones you have to work out. And it's actually really easy. Again, we just have to keep the math straight. Radical 5x, we're going to FOIL it. We're going to wrap this up and we're going to FOIL because there's 4 terms there. This times this, any radical times itself is just itself. So this is really just 5x minus 1. Now this times this term is going to be a positive 2 times the square root of 5x minus 1. This times this term is going to be a negative 2. So I'm just foiling the square root of 5x minus 1. And then this, the last terms, is going to get me a negative 4. Now, if you multiplied by the conjugate multiplication is always nice because the middle two terms should always cancel. Positive 2 radical 5x minus 1 and negative 2 radical 5 minus x minus 1 cancel out. So I really have the top over the bottom. And I'm slightly running out of room here. So I still have the limit as x approaches 1. So I'm leaving the top. I am never going to touch the top if it doesn't have two radicals. 5x minus 1 plus 2. And I'm just going to clean up the bottom. So I have 5x minus 1 minus 4. So that becomes 5x minus 5. Those are like terms. I can put them together, the minus 1 and the minus 4. Now you might be thinking nothing's happening. And so here's the deal. If you did it correctly, something should cancel. So what can I do to make things cancel? Well, I can go back to that really simple idea of a GCF. In this denominator, I can pull out a 5, and then I'm left with x minus 1. And that's how you know you did it right, because if the numerator and denominator cancel, you did it. So right here, I can divide this x minus 1 with this x minus 1. So I end up with, I'm just going to put an equal sign here, the square root of 5x minus 1 plus 2 all over 5. And then I'm carefully going to go back to direct substitution and reevaluate this, plugging in a 1. So 5 minus 1 is 4. The square root of 4 is 2. 2 plus 2 is 4, all over 5. So it looks a little messy and intimidating, but I'm going to slow down and try it again before I give you one to practice. But the key idea is that you have to keep things nice and neat and multiply by the conjugate of the reciprocal. All right, so let's try this one. Let's go ahead and I'm going to pause it and do direct substitution. All right, so you can see my direct substitution over here. I substituted in my negative 3. I ended up getting 0 over 0, which again is called indeterminate, which says you're not done, keep going. So I rewrote my problem, and I'm going to multiply by the conjugate of the radical. So the radical could be on the top, it could be on the bottom, it doesn't matter, but you're always doing the conjugate of the radical. So I'm going to say times, and I'm going to go with times the square root of 4x plus 28. And this time I'm going to do a plus 4 because I'm doing the conjugate of that radical. Whatever you do to the top, you do to the bottom. Now the rest is just simple algebra that we just have to keep straight. I mean, that's really the calculus part, the hard part. Multiply by the conjugate. All right, so let's go ahead and keep our calculus, or our multiplying, I should say, straight. The calculus part is kind of over. All right, so I'll start with the bottom. Because this piece doesn't have a radical and this one does, you do nothing with it. You just rewrite it down. Easy peasy. I'm just rewriting it down. One has a radical, one doesn't. The top part, because they both have radicals, we do have to multiply out. And again, just to reiterate, for those that didn't believe me about the radicals, radical 4 times radical 4 is really radical 16, which is really just 4. So any radical times itself just becomes the stuff under the radical. So I'm going to wrap the top I'm going to wrap this piece and I'm going to FOIL. This times this, any radical times itself is just itself. So that just becomes 4x plus 28. Okay, now if you can do the next part in your head, that's perfect. This is going to be this radical times a positive 4. And then when I do the insides, it's going to be negative 4 times this radical. They're going to cancel each other out. If you want to write it all out, that's totally up to you. But the whole point of conjugates is that the middle terms cancel out. So I am not going to put it in there. And then I'm going to do my last term. Negative 4 times positive 4 is going to get me a negative 16. So again, my middle terms canceled. You are welcome to write it down, but you do not have to. And I'm going to clean this up. Actually, in calculus, the less work you show is better, but we'll get to that point. So I'm going to clean this up just over on the side because I'm running out of my room here. I have 4x. What's that going to get me? Plus 12 over this denominator. Now remember, you know you did it correctly if something cancels. So you might be saying, oh, shucks, nothing's canceling at the moment. But don't forget, you have factoring in your pocket. So I'm going to go back and factor that numerator. And I can pull out a 4 as a GCF. So I have 4 times x plus 3. My x plus 3's cancel. So I did it right. They canceled. So I really have 4 over this piece here. And I'm going to use direct substitution to evaluate that. So I have my limit as x approaches negative 3. I'm going to plug in my negative 3. So I have 4 over, let's see, I have the square root of 4 times negative 3 plus 28, and then a plus 4. So it's negative 12 plus 28. That's going to give me 16, which is then going to give me the square root of 16, which is 4. So I have 4 over 8, which I believe should get me a 1/2. And there you have it. So again, pause it, rewind it, ask questions. We're here to help you. All right, so number 7, I'm just going to pause it, work it out completely. You try the same thing, and then we'll compare work. All right, I'll run through my work. I did get indeterminate 0 over 0. So I'm multiplying by the conjugate of the radical. So I did the 2 plus the radical x plus 1 to the top and bottom. Notice on the top, this piece on the numerator here, they don't both have radicals. I'm just writing them down. The bottom I noticed is the place where you could make a mistake. So when I FOILed, 2 times 2 is 4. Middle terms canceled. I didn't choose to show them. Now the last term, x plus 1 times radical x plus 1 times radical x plus 1 is x plus 1. And it's going to be a minus, but you have to make sure you subtract this whole quantity because you have to take this negative and distribute it. So to me, anytime there's a negative, that's a place, an easy place students make mistakes. So when I distributed that, I got negative x plus 3, which you can see over here. So then I'm going to say, okay, those don't match exactly, but I can factor this denominator by pulling out a negative. So I have my x minus 3's. These will divide out. So on the bottom, I basically just have negative 1. And then when I plug in my 3, I get a 4. So I would say I get a final answer of negative 4. All right, I'm going to skip that one. I think we did a couple of those. All right, I've got maybe 2 or 3 more here. Let's get into a trig one. All right, so I'm going to do a direct substitution, of course. So I've got the cosine of pi over 2. Now the squared, I take that whole answer and square it, okay? Because I can do the cosine of pi over 2 and then just square your answer. Divided by the sine of pi over 2 minus 1. So now again, pi over 2 is on the graph. I'm going back to my graphs when I think of these. So I'm going to do cosine. Starts at its max, hit 0, min, 0, max. Pi over 2 is my first tick mark. So the cosine of pi over 2 is 0. 0 squared is 0. The sine of pi over 2 starts at 0, max, 0, min, 0. The sine of pi over 2 is 1. So 1 minus 1 is 0. So I have indeterminate. So now there's nothing really to factor. There's no conjugate because there's not a radical. Now you have to use your trig identities. And you might be thinking, what the heck? It's been so long. And it has. So I'm going to go back to the basic trig identity. And again, you'll want these in your notebook. Sine squared plus cosine squared equals 1. It's kind of like the Pythagorean theorem. A squared plus b squared equals c squared. We'd put trig into it. Sine squared plus cosine squared equals 1. And we're not reteaching it. It was just, we did this in Algebra 2. So now I need cosine squared, and I can manipulate this function and get cosine squared all by itself. All I have to do is subtract sine squared from both sides. So cosine squared now is equivalent to 1 minus sine squared. So I'm going to replace this cosine squared with 1 minus sine squared theta all over the sine of x minus 1. Now you might be thinking, why did we do that? Those still aren't the same. One is sine squared, one is sine, they're not equal. But what you can do is factor that numerator because they are perfect squares. One is a perfect square and the squared function is a perfect square. So I can say this is equivalent to 1 plus sine of x and 1 minus sine of x, since they are perfect squares. Now, you'll notice these don't match up exactly. They're basically different by a negative. 1 minus sine x minus 1. 1 is positive, now it's negative. Sine is negative, now it's positive. So these do divide into a negative 1. So I really have negative 1 minus sine of x. And I can now substitute in my pi over 2. So I have negative 1 minus the sine of pi over 2. I'm going to go back here as 1. And negative 1 minus 1 is negative 2. So the trig are a little more intimidating, and we'll do much more in class when we get there in September. But we just wanted to introduce you to them. All right. Number 10 is our last one, and this is complex fractions. We did a lot of these in Algebra 2. We'll start with our direct substitution by plugging in a 3. So I'm going to get 1/9 minus 1/9, which is obviously 0, over 3 minus 3 is 0. Okay, so we know we have to use some sort of manipulation here. So just to recall, since it's been a while, our goal is to get common, that should be a 1, denominators. So this is x over 1 minus 3 over 1. Since they don't have denominators, the x and the 3, we just put them over 1. So now everyone's a fraction. And you just ask yourself, what's the common denominator? Common means you want them all to be the same. So they all would need an x squared, since x squared is in the denominator. And they all need to multiply to 9, since 9 is in the denominator. So the least common denominator would be a 9, and an x squared. So I'm going to make sure everybody has a 9 and an x squared. So this bear is going to get multiplied by 9, and whatever I do to the bottom, I have to do to the top. So that has 9x squared. This guy's going to get x squared, and again, whatever I do to the bottom, I have to do to the top. This guy needs a 9 and an x squared. And this guy needs a 9 and an x squared. So again, my goal was just to make 4 fractions that are the same. So right now I have 9 over 9x squared minus x squared over 9x squared all over 9x cubed over 9x squared minus 27x squared over 9x squared. So why did I make them all the same? Well, now I can add those fractions together. Once we have like denominators, we can add them together. So now I have 9 minus x squared all over 9x squared divided by, I have 9x cubed minus 27x squared all over 9x squared. And as long as you have a complex fraction, so fractions within fractions, and the denominators are the same, they actually just divide each other out. They cancel out. So this 9x squared and this 9x squared, because they're both the same denominator, divide out. So I have 9 minus x squared all over 9x cubed minus 27x squared. And all I need to do is factor and clean that up. So we'll go through factoring again. I'm on top 2 terms, either have GCF or perfect squares. Clearly there's not a GCF on top, so I have perfect squares. So the number came first, that's going to be 3 plus x and 3 minus x. On the bottom, 9's not a perfect square, neither is 27 or x cubed, so I can pull out a GCF. I'm going to pull out a 9 and an x squared. So then I'm left with x minus 3. And you'll notice x minus 3 and 3 minus x, they are different by a negative, so they divide into a -1, which I'll put right on top here. And now I just have to evaluate that limit at 3 again. So I'm sorry, I'm running out of room. I'm going to kind of work backwards here. Actually, I might have a little here. So I have negative, I have 3 plus 3. So that's going to get me -6. And on the bottom, I have 9 times 3 squared. 3 squared is 9. 9 times 9 is 81. And you can reduce it or leave it. It doesn't matter. But we've got our final answer there. The limit as x approaches 3. So I know I threw a lot at you. Hopefully you paused it when you needed to, went back. Remember, we have office hours on Wednesday to ask as many questions as you need. And don't hesitate to email, text. We're here to help as much as we can.